Hi everyone, in this video we are going to examine the graph of an ellipse, identify important parts like the center, vertices, and foci, and learn how to write the equation of an ellipse from that information. Let's get started. An ellipse is a set of all points where the sum of the distances between those points and two fixed points that are called foci are constant. Now each ellipse has a major axis, which is the longer one, and a minor axis, which is the shorter one. Now, the foci of the ellipse lie on the major axis, and it's c units away from the center, and we have a little formula to help us to find our c value. So c squared equals a squared minus a b squared. Now a is going to be the distance from the center to the vertex, and then b is going to be the distance from the center to the co-vertex. Now let's go ahead and label this information here. So we have our two foci. We have a major axis, so again the longer axis. You also have the minor axis, which is the shorter. You have your vertex here and here. So again, that's going to be on the longer axis. You have your co-vertex. And then you also have the center. So your ellipse can have either a horizontal major axis or a vertical major axis. Now, the best way to look at that is to look at the a value. Now, the a value is always going to be greater than the b value. So the a value here is larger along the x or the horizontal axis, and the a value is on the y, which makes the vertical axis the major axis. Now, when you're writing the equation of an ellipse, they are very similar. So our center is always going to be hk. Now again, h is our x-coordinate, and k is our y-coordinate. Your equation is always going to be equal to 1. Now, to fill in the rest of your equation, you again have to look at that major axis. So if the major axis or that a value or the longer of the axis is on the horizontal, which is your x, the a squared would go in that first fraction. And then b squared is going to go in the second fraction. Now, if the a value is on the vertical axis, you're going to put that a squared where you have the y, so in that second fraction. And then, of course, the b is squared is going to go in the first fraction. So remember that your a value is always going to be larger than your b value. That's how you're going to know which axis is your major axis. So you have your equations, you saw your sketch. Now, in order for you to find the length of your major axis, you're just going to multiply that a value by 2. To find the length of your minor axis, it's going to be multiplying that b value by 2. And then to find the area of an ellipse is the same. It's pi times that a value times the b value. Now, these couple other points are going to be important for you to remember, right? So your a distance is always going to be from the center to your vertex. The b distance is the center to your co-vertex. So that's how you know that the a is always going to be on that longer axis. Now the c is always going to be from the center to the focus. And then hk is going to be the center of your ellipse. So let's look at some examples together. In this example, the ellipse is not in standard form. So the way that you know that is the 36. So you want to have it equal to 1. So we're going to divide everything by 36 here. So that would be 4 over 36, which is the same thing as 1 over 9, or x squared over 9. You're going to have y squared over 36, and 36 over 36 is 1. Now here, what you're going to be able to tell with your orientation is that the larger value is right here. This is your a squared, which means it's on the y, which means your orientation is going to be vertical. So you're going to have a vertical major axis. And then this one is going to be your b squared. Now, in order for you to find the center, right, we are looking at the x squares and the y squared. So if you had a number there, that would be your center. But we know that if there's no number there, it's 0. So your center is at 0, 0. To find your vertices, you're going to look first at the a squared. So if I take a squared and I set it equal to 36 and I solve, which means I take the square root of both sides, my a value is going to be positive 6 and a negative 6. Now, because my orientation is vertical, that vertices that I'm going to plot are going to be on the major axis. So I need to go up 6 from my center and down 6 from my center. And that would be my vertices because this is always the major axis. When you look at your co-vertices, that's going to be on the minor. So that's the b value there. So b squared equals 9. So b is plus or minus 3. So I'm going to go to the right 3 and to the left 3. Now I can write those coordinates for those points. My vertices would be 0, comma, either positive 6 or negative 6 or plus or minus 6. And then for my co-vertices, I'm going to the left. So I'm either going plus or minus 3, comma, 0. Now, in order for me to find the length of my major axis, I'm going to take 2 times a, or 2 times 6, which is 12. And then the minor axis is 2 times b, or 2 times 3, which is 6. Now, if I want to find my foci, or my focus, right, I've got 2 of them, that is my c value. So I'm going to have to use my equation c squared equals a squared minus b squared. Now I'm going to plug in my information. A squared I know is 36 minus b squared, which is 9. That gets me 27. So c is going to be plus or minus the square root of 27, which I know is the same thing as 3 square roots of 3. And that is approximately about 5.2. So it's going to be along the major axis. So I'm going to go, let's see, about 5.2. There's my one focus, and there's my other one. So I've got 2 foci there. Now, to write those points, because you don't have a nice number here, we can use that radical that you had. So the x value is 0, and then you can just write plus or minus 3 square root of 3, right, or plus or minus square root of 27. Now that you have all that information, you can draw your ellipse and do the best that you can to make it sort of curved. Now, to find the area, we know the area is pi times a times b, which I know is 6 times 3, which is really 18 pi. So my area is 18 pi. Okay, here in example 2, if I look at my equation, already equal to 1, so that is good. So I'm already in standard form, so I don't have to change anything there. I do want to look for where is my larger value. So 25, here is a squared, this is b squared. So because 25 is on the x, you're going to have a horizontal orientation or horizontal major axis. I look at my center here, which is 2 and negative 3. Now remember, those signs are changed because in your formula, remember, it's always x minus h and y minus k. So if my signs happen to flip, that's what my signs are going to be for my center. So I got 2 and then negative 3. My vertices, here we go. We are looking at our a value, which is going to be plus or minus 5. So I know it's horizontal, which means in the x direction, we got to go 5 to the right and 5 to the left. And you can write those points there, 7, and then negative 3, and then negative 3 and negative 3. My co-vertices, that's my minor, so that's my b value. So b squared was 16, so b is plus or minus 4. So in the y direction, go up and down 4. And so you got 2 vertices there, 2 and 1, and 2 and -7. So the length of my major axis is, again, 2 times a, or 10. And the length of my minor axis is 2 times b, which is 8. My foci, again, remember, is my c value. So I've got c squared equals, and then a squared is 25 minus b squared is 16. So c squared is 9. C is plus or minus 3. So again, it's going to be along the horizontal. So I'm going to go 1, 2, 3 along the x. And then 1, 2, 3. So those points are 5, -3, and -1, -3. You have all your features here. So again, let's draw your ellipse. And then we can find the area. So we are going to have pi times 5 times 4, and that gets you 20 pi. All right, so here we're going to go ahead and write an equation of our ellipse. So we have 2 of our vertices right here given to us, and we have our foci, which is right here. Okay, so let's go ahead and see what we can sort of draw for ourselves to give a little bit more information. We've got -3 and 2, and then we have 11 and 2. So we'll say this is 11, this is -3. Now, because you're given vertices, this is going to be on your major axis. So when you're looking along there, that's your major axis. That's along the horizontal. So this will be a horizontal orientation here. What we can do is, if we want to find our center, right, we know we have to be in between those points. So to find our center, we're going to look at those x values. If I find the direct middle between those x values, we get 8, and then we get 4. I know that 4 has to be the center for my x, and then the y has to be 2. So I found my center, which is at 4, 2. So I know that information. You can find the a value. Now, the a value, again, is this distance between your center to your vertex here. So from 4 to 11, that a value is going to be 7. Okay, so you can put your foci. Here we got -1 and 2, and then 9 and 2. So from the foci, you can find the c value. Now the c value is, again, it is this distance between your center to that foci. So that's that c value. So we got from -1 to 4, that's a 5, distance of 5. So we have A and we have C. You can find B. So when we look at our B value, here we go. We're going to use that formula that we had. So you've got 5 squared is equal to your A squared, which is 7 squared, minus B squared. So you're going to have 25 equals 49 minus B squared. Let's subtract 49. That'll get us -24 equals -B squared. Divide both sides by -1. B squared equals 24. Now, again, because our orientation is on the horizontal, we're going to use the respective formula here. And remember that the horizontal is the major, so that means our a value is going to be right where the x fraction is. So it's that same fraction there. So let's put in the information that we know. We have x minus, and then our center is 4. And then y minus, and then a center that was 2. So always equal 1. And in my fraction, I've got a squared, which I know is 49. And I know b squared, which I just found, which is 24. Now, I hope you found this video helpful. Don't forget to like and subscribe for future notifications on other pre-calc videos. Thanks for watching and have a great day.